Green light. Green light. Let's go. So, oh, this was kind of cool. I gave this to my freshmen yesterday. So I said to them, hey guys, and if you want to do this, you can, like for fun. Yeah, I do things for fun. So, um, you're gonna buy a pony for $1,250. You have 3 coupons. One is for 20% off, one's for 30% off, one's for 40% off, and you can use all 3 of them to get your discount. But you need to choose what order you're gonna take them in, right? Because you want to pay the least amount. So you're gonna pay the pony cost $1,250. You have these 3 coupons, and their task last night was to figure out what order they were going to take these discounts in to get the most discount. So you guys, I think I posted this. This is what I posted, right? Yeah. You were doing it? What did you come up with?
Something in the 300s.
That's pretty fun. What did you do? Did you do 20, 30, 40, or 40, 20, 30?
I did. You said any order, right?
Any order.
I did 30, 20, and then 40.
30, 20, and then 40? What about any? Did you try any other combinations?
Yeah, but I forgot what I got after that.
Pretty cool problem. I thought that was fun.
Yeah, we should do it. That's what we should be doing.
Yeah.
You know, this is not really this hard, guys. What we're going to do today, the logarithm rules. But I just wanted to show you. So let's get to this, because we need this part. Okay? If you want to do that problem, catch me on the gram. Go back. It's just properties. We're just going to do properties today, okay? So let me tell you what I mean about with this problem. So when we're talking about the product, let's say that we had the log of log base 3 2x. Log base 3 2x. And we're trying to simplify this always, right? As much as we can. Now, obviously, we really can't do much because there's an x in here. But what I can do, since this is really 2 times x, I can split the 2. I can say this is simply log base 3 of 2 plus log base 3 of x. And if there was a number for log base 3, 2, then I would just substitute that in because that part can get simplified. Questions on this rule? Pretty simple rule, right? And of course, all these rules also work in reverse. If I have the sum of 2 things with the same base, I can convert them back into a product if I wanted to. Questions here? Thumbs up? We're good? In the back? Let me see those thumbs. All right, cool. All right, cool. Can I change the slide? Good. Okay. So here's an example. If I had the log base 6 7 times 11, I could break that up into log base 6 of 7 plus log base 6 of 11. Simple enough? Here's the next rule. If I have a quotient, then the quotient can be split up into the difference of the 2. It would be the log of the numerator minus the log of the denominator.
I have a question about the last.
What's up?
If it was like instead of 7 times 11, and it was just 7 to 7.
You could split it up if you wanted to into 2 products. Yeah, definitely. So here's the question. And you could do that with any one of these. So I'm going to jump back real quick. Actually, I'll do it right here. Let's say that you have the log of, let's do 70. Let's do log of 70, okay? And we're trying to simplify log of 70, okay? Here's what I know. I know that I could make this into log 7 times 10, couldn't I? That means that I would have log 7 plus 1. Because this would be log 7 plus log 10, right?
Log 10 is your base.
Yeah, so 10 is my base. So 10 to some power gives me 10. That would be 1. So you can do that. Absolutely. Fantastic question. Thanks for asking that.
Leave that right
I will. What happened? No, this is a no dab zone. This is a no dab zone. You are not allowed to dab. I was stretching my arms. Or flexing maybe. I don't know. No. Oh my god. I had so much of that like 2 years ago. I had a kid like, I'm dude, like, you're gonna get whiplash. He's like, what the heck? How you do that there? Like, no, yeah, when the dab was like at its peak, I said, no, this is no dab zone. You're not allowed to dab in here. Buenos días. ¿Cómo está? Ready? Okay, here's an example. If I had log base 8, 23 over x, then I can separate that into log base 8, 23 minus log base 8x. Now, I do want to point this out. Addition is commutative, right? So it doesn't matter which one I choose to write first. Does it matter with my division? Yes, it does, because division is not commutative. So make sure that you're doing numerator minus denominator. Okay? All right, cool. Try this. Try this out. Simplify this for me.
Without using a calculator?
Yeah, you don't really need one. Do this by hand. Oh, you might need to use a calculator. Stop writing. Oh my god, this is annoying. Just an FYI.
Wait, where do you find the log of the base? Like, where do you find that? In math, right? So we're thinking we hook up.
Alright guys, so like pretty much some of you guys
Okay, here we go. So what's this going to become? ln, hold on, that's an M. JK. ln, what is it? E to the 5th minus ln 11. So that's just 5 minus ln 11.
I didn't write mine exclusive. I wrote it in
Yeah, and if you want to throw it in your calculator, that's fine. This will be okay if we're doing it by hand. If you're doing it on MATLAB and it wants a decimal, then do that. But it's also going to ask you just to simplify.
Oh yeah, the
equal to log with a base of e. So if I write it as log base e to the fifth, powers and logarithms are inverse operations, therefore they cancel each other out, and you're going to get just that power up there, that exponent I mean. How you guys doing? You guys okay so far? Not bad? This is not too difficult. I can change the slide? Gone. Okay. Now, this is the power rule. This is the power rule. If I have some logarithm, let's do this. Let's go log base 3. If I had some power like this, I can take this exponent and kick it to the front. So this can be rewritten as 5 times the log base 3 of x.
That seems very simple.
That's the rule. If I have a power, the log of a power, I can take the exponent and kick it to the front and write it as, let me color code this for you. That's that same 5 right there.
I remember simplifying those. I think Mr. Ross was a good teacher.
Waterfalls. What's up? You can. That's a rule. Because if you really think about this here, let me step back a little bit and. Let's see here. If we did a conversion, 3 to the x would equal x to the 5th, right? That's not going to help. Okay, let me write that down and I'm going to have to go back to you on this. Okay? No, I don't know why. I never really questioned that. Like, I know it just is a rule. So just by looking at it, here's what makes sense to me. We're taking the log, we're taking this to the power of 5, right? So that means we would take log base 3x times log base 3x, log base 3x, log base 3x, log, because I couldn't fit the other one there, right? Isn't that what this is saying? Yeah. This times itself 5 times? Is that not equivalent to 5 times log base 3x? I just had to think about it a little bit, but.
Mr. Nunez, I was doing the one problem with the coupons, and I just keep getting the same answer no matter how you rearrange it.
Isn't that cool?
It was a trick question.
It's a trick question. The point, yeah, so.
I know, when I was reading it, I was like, what?
Yeah, so it doesn't matter what order you take the discounts in, which is a gimmick that a lot of places like Kohl's or Target will use. They'll put their discounts on. Like, they know what they need to make a profit, how much to sell it for. So what they'll do is like, oh, you know what, we have this stuff on sale. And if you come in, you can use my 20% off coupon, right? So they don't really care. And then sometimes you can stack them. They already know what you can do. And if you miss one, then that's good for them, right? But they already know how much money they're going to have to sell that for in order to make a profit. So all the other stuff is just gimmick.
This is for a pony? I feel like $420 would be worth it.
Yeah, we also have to think about the
Well, the only reason that we put pony up there is because as we were doing the problem, I let them choose what they were going to buy. And someone said a pony, I'm like, really, a pony? Like, yeah, a pony. And I was like, what? I was thinking someone was going to say like an Xbox or something. No. not saying that that's the real reason. You're saying if you put real numbers in here?
Because like maybe log should be plus. When you multiply plus and you put the exponent.
No, this is not plus anymore. This is not the product of two things. Where'd it go? It's not this. It's to an exponent. So there would be an exponent here. So if I found this number and I did that 5 times, that would not be the same thing as multiplying the whole thing by 5? Not really? You're right, it's not. Because I'm only going to be taking 5 times. So let me look for the real reason. Okay? It's not right.
Can I go wash my eye out?
Yeah, go for it. Hey, heads up. Thank you. So this that I gave you here, I already got a, hey, thank you. So what I said here is not true. Okay, what I said here is not true. I'm going to look for the real reason. I'm going to give that to you. So it's still in my notes, but that's what came to me in my when I first saw it first. That kind of made sense, but it wouldn't make sense because taking something times itself 5 times is not the same thing as 5 times something. Like if I were to, if the number was 2, right? 2 times 2 times 2 times 2 5 times is 32, but 5 times 2 is only 10. So, Maddie, thanks for pointing that out.
I was thinking the same thing. I heard you say it.
All right, cool. So let's move on. I'll get you a real reason why that's supposed to work. We'll find you the proof. That sounded fancy. Let's see what else we got here. Da, da, da. We should practice these. Try this out real quick. Rewrite this in simplest form. Yeah. All right. And I'm going to search for the proof already.
I feel like I can reduce all this by 3.
It's just 9 1 6 to the third.
Yeah, but everything is reduced by 3.
The police or whatever, they're so funny. No, there was more adults yelling at each other in the street.
I think we're just supposed to simplify, right? You don't want an answer?
No, he didn't want an answer. He was like, hey, we'll go over it cheaper.
Oh, they're all in the Khan Academy. So here you should have done 9 times the log base 6 of 3. Sorry, log base 6 of 3.
Wait, can you factor it out?
Can you factor it out? What do you mean?
What do you mean? He means, can you simplify or reduce everything
Yeah.
by 3?
Can you like take out a 3?
No.
No?
No. No, because this is 9 times whatever this is going to be.
Oh, okay.
Okay?
Evan, let me see my pencil.
Can we play around? This is really. Let's do something like log base 3. Let's do 4 to the 3rd. So let's change this base just so we don't confuse any of the numbers. 2? Just because I really want to see what's going on here. So,
So 3 log 2 base 2 to 4.
so if we use one of the rules here, this is really, oh! Let's see, so I'm just looking at the power rule again. Here's what I'm thinking. Isn't this technically log 2 of 4 times 4 times 4? Right? So wouldn't that simply be log base 2, 4 plus log base 2 of 4 plus log base 2 of 4? Right? Because of the addition rule that we just did? This is 4 times 4 times 4. Right? If I were to work this out. So, I was right on my proof. Because of the way that this is logarithms and not actual, we're not working with the real numbers. If I broke this up this way, this is equivalent to saying this is 3 times log base 2 of 4. So yay, I was right. But your argument made a lot of sense too. Maddie, I just want to say your argument made a lot of sense too. Thank you for saying something.